Assalamualaikum warahmatullahi wabarakatuh and very good morning. My name is Khairul Alwan. I will present to you about the design of a grid-connected PV power system for residential application in Argentina. So the first one, I will go through the introduction. Photovoltaic is made up of one or more solar panels and inverters and other mechanical and electrical components that harness solar energy to produce electricity PV system. So for the PV system, come in wide range of size from little rooftop or portable units to enormous utility scale power plant. So for the process solar cell, we call it photovoltaic effect, which is light that converts to electrical energy and flow to the load. There is a measure of agreement that Argentina Solar Resource is ideal for photovoltaic and solar thermal development both for large and small scale distributed installation. And for design problem, have three, which is high cost and availability and intermittency. High cost because of the PV system, which has inverter in, and the material to build the PV system is high. And we go through the meteorological data analysis. So this is the data and graph of monthly average. As you can see, average PSH. So this is the graph from the value that we calculate just now. So you can see the higher is January and the December, and the lowest is June. So this is the explanation. Highest average temperature flat on January, which is 28.78, and the lowest temperature in June, 12.47 degrees Celsius. June has the lowest temperature because Argentina winter month. That month has winter and June to August. And the highest PSH data is recorded on September, which is 5.94, and for the lowest PSH, 3.14, which is on June. According to the data taken, average PSH for this location approximately around 4.55, and total PSH taken about 1659.16. So this is the load profile, which is the maximum demand, the energy that used. So this is the explanation for the load profile. Has been taken for different sources input, which are lighting, video appliance, refrigerator, and others. So the data load profile has been recorded for 24 hours, which is 1 day. The highest consumed hours load demand at 22 hours, approximately about 0.852 kilowatt, and the lowest consumed hours for load demand 5 hours, which is approximately 0.392 kilowatt. And the lighting contribute highest load for household at Buenos Aires, Argentina. So the total power input or load demand around 13.18 kilowatt. So we'll go to the design PV system, which is solar panel. So this is the component that use the datasheet, which is Sunset SCP250S, 20 watt for power. So this is the parameter and value. And for inverter, Huawei Sun 2000, 6KTL M1. This is the parameter and value. So this is the equation for the power sizing for the solar system power sizing. This is the formula. It's obtained from previous calculation within load profiling. For daily, 13.188 kilowatt hour, and for yearly, 4813.62 kilowatt hour. So the PSN, which is peak sun hour from the weather data, which is 1155.04 kilowatt hour per meter minute. So all the other value according to the value stated. So for this, the rating factor, average maximum cell temperature, this is the formula that using for the equation, and get 0.8416. So this is the system size and number of modules. This is the formula, about 5 kilowatt. And we can get from 5 kilowatt about 20 modules. So one module about 5 kilowatt. So the inverter sizing, this is the formula, and K is the constant 0.95. From the data sheet, we take 0.95 times 5 kilowatt because of one module, about 5 kilowatt for solar panel, about 4.05 kilowatt for inverter. So the series arrangement of solar panel. So this is the maximum open circuit voltage and get 38.0358 volt. For the maximum number of modules in series, about 27.47 units for panel in series. So we round off about 27 units maximum in series. So this is the parallel. This is parallel for the inverter. So for the formula, number of parallel string is shown below, about one string. So the rooftop and panel area. So this is the formula for finding the area of the rooftop and panel. So for the roof area, about 39.052 meters square. So this is the area for roof, which is smaller than the average size of house or building. So this setup is possible. So the weight that sun and for the roof about 436.8 kilograms. So the weight of solar panel can support at the roof. So this is one line diagram. As you can see, that's used 4 strings, and for one string about 6 panel, and use 1 inverter. So for the cost analysis, this is the price for solar panel per unit. About one solar panel, 644 ringgit 0.80, and for the end inverter, 9,379.39 cents. So for the installation for the PV system, assume about 4,000 ringgit, and the capital investment, which is cost of the material for solar panel and inverter, is about 26,858 ringgit 59 cents. So the annual cost saving, estimate yearly system size about 6 kilowatt, and for the ROI, which is return of investment, about 8 years for the ROI. And this is the discussion. So PSS for this location is around 3.16 kilowatt hour, which is at the Buenos area, and the total PSS taken about 1,155.04 on 2021. So the purpose of the PV system is for residential application. Paper has been researched with data on each household total power input or load demand is around 30.18 kilowatt. So they estimate that the PV module about 20 modules for support each building. However, 24 modules were the optimal sizing after figuring out the size of inverter and arranging the solar panel. So the specification of roof determine roof area about 39.045 that calculate just now. Also support total weight of solar panel is 436.8 kilograms. Also the calculated just now. So using feed rate as a guideline, it can be observed that ROI is in less than 8 years. So the 8 years is the assume for 8 years for ROI. So the conclusion for this project. So the project was a success. Students were able to record daily solar radiation and temperature data on provided website and plot the monthly data using microfactors, which is using the temperature that record daily, every day. So the students were able to analyze the meteorological data in designing photovoltaic system for Buenos Aires, Argentina. Other than that, students also able to configure the daily load profile for residential application. And the last one, students able to design rooftop grid connected photovoltaic system for residential application. As you can see just now, the calculation and the design for rooftop. This is so the students were well enough to do the design rooftop grid. So that's all for me. Thank you.